Hello and welcome to Data Analysis and Visualization in Python. This is the third video in the series. In the previous video, we learned about some basic and advanced concepts of Python that are going to be helping in this course in the future. And in this video, we are actually going to be stepping bounds on actual data analysis tools. And we are going to be learning about the Python numPy library. And so let's get started. So NumPy library is a multi-dimensional numerical library which can perform simple and complex tasks on huge numerical data efficiently, and it's super fast. NumPy is mainly used for working with arrays, and arrays are basically the main data type to represent and manipulate data. Right. So usually in Python we do have a lists that serve the purpose of arrays, but they are slow to process. Now, NumPy basically provides an array object that is like up to 50% faster than the traditional Python lists. So let me just show you how. So why do we need to use NumPy? Well, first of all, NumPy arrays have fixed type, while lists size change dynamically. What I mean by this is that NumPy arrays have a fixed size at creation, unlike normal Python lists, which can grow dynamically. Changing the size of an NumPy array will create a new array and delete the original one, while in normal Python list, it just adds an element to the list. So let me just explain a little bit about this. So you know the normal Python lists, right? They do not have a specific data type declaration, which means you can add basically integer, float, strings, boolean, etc. in one list together. And so whenever an element is added, there is a lot of information that is added alongside that element. Like for example, object type, which takes 8 bytes of memory. Object value, the value of this object, 8 bytes, and its reference, which is also 8 bytes, and the size of this element, which is also 4 bytes. All these things take about 28 bytes of memory. And so whenever an element is added to a list, there is an additional 28 bytes that are required. While in case of the NumPy arrays, there is a little bit of information about the array, like the dimension, size, and its shape. But whenever an element is added, there has to be the declaration of the data type in NumPy. And so by default, the data type of NumPy arrays is int32, which is a 32-bit integer, and it takes about 8 bytes by default. And whenever an element is added to the NumPy array, only 8 bytes are required, unlike lists that require about 28 bytes per item or per element. And so when you have a large amount of data, NumPy arrays are faster and more efficient in terms of memory. And when you're using, for example, these all numbers are smaller numbers, right? And we can basically declare in the NumPy array that we want the data type to be int16, which is a 4-byte integer, instead of using the normal int32, which is the default value in NumPy array. And so NumPy arrays are significantly faster than lists. Second of all, the NumPy arrays have contiguous memory. What I mean by this is that, for example, you have a list here, right? And here is a list, and each element of the list is located somewhere in the memory. Now, in normal Python lists, what happens is that each element can be placed in different parts of the memory. Like second item is here, and the third item is like on this side. So these are all scattered. They don't have a consistency. While in NumPy array, the elements of an array are contiguous, which means in memory they are located right next to each other, and it's easier to locate and access them and reference them. And so while performing operations on a huge amount of data in an array, the accessibility of the values is like very easy and making NumPy arrays significantly faster. So normal lists are very slow for big data, and NumPy is like as comparatively really fast. Operations like matrix multiplications are easily performed on NumPy array, but in lists, in fact, we can't even multiply two arrays together. Element-wise multiplication or element-wise operations are very hard to do in normal lists, so that's why we use the NumPy array object, which basically has the ability to operate on a higher level. Okay, so let's take a look at the working of the numpy library. In Python, what you do is first of all import the numpy library as follows. Import numpy as np for short, so it's easier. And if you run this, there should be no errors. And if there is some sort of error that you can't import numpy, uh, if you have written it exactly in the same way, what you're gonna do is you're gonna type in here pip install numpy and then run this. It should really install all the required things. And so you can see right here it says requirement already satisfied because the numpy is installed here already. I'm sure on Google Colab numpy is comes with pre-installed. So yeah, let's just import that. All right, so one of the few basic things that you should know in starting is how to make an array with the numpy, a numpy array object, as I previously mentioned. So what you're gonna do is you're gonna make an array. For example, I make an array equal a equals, the syntax is np dot array, in brackets you're gonna add a list and add the values to it. And so if I print this, it basically shows us the array. It's shown exactly the similar as a normal list in Python. One of the handy and most important things that NumPy library basically offers us is the ability to create multi-dimensional arrays. So what we're going to do now is we're going to create an array B, which is going to be a multi-dimensional array. So np.array, and right here we're going to create a list, and inside this list we're going to put two lists. For example, this list and this list. So can you see that? Like, let me just put some spaces here. All right, so in the brackets there is a list, and inside that list there are two lists. So let's fill them up with the values. All right, so we're gonna print this up now, and if I run this, you can see that we have now a two-dimensional array with values 234 and 234. These are the rows, and there are two rows and three columns. What we can do now is we can check b dot n dimensions, ndim, basically b dot ndim, which means the number of dimensions. So we want to know how many dimensions our array has. So if I run this, it should give us 2. So we have a list of lists, and this is called a two-dimensional array. So another thing in numpy that you should know is the shape of the array. So if I write b dot shape, it should say 2 by 3, which means basically there are 2 rows and 3 columns. As you can see, there's 1 and 2 rows and 3 columns. The data in numpy array is basically somewhat similar to a spreadsheet, right? There are rows and there are columns, but there are also dimensions, numerical dimensions, which I'm sure you'll understand once we reach the other library part, which is pandas, because numpy is base for the pandas library. And once you reach there, you will understand a little bit in depth about what dimensions are and the overall structure of data. So moving on, we got to know how to make an array. We got to know how to make a multiple dimensional array. Now I want to show you something interesting here. We know that the multidimensional array is as follows here, right? But let's suppose that we have an array, a multidimensional array, c equals numpy dot array. So we create a list, and this list will consist of lists, right? Let's suppose we have 3 lists inside this list. So let's fill this up: 2, 3, 5, or 6. And in the third one, I'm gonna say 4, 3, 6, 2, and 1. Notice how all the other lists inside the list have 3 elements, and this one has 4. So if I try to run this, what happens is that it will give us this warning: creating an array from ragged nested sequence, which is a list or tuple of lists or tuples or ND arrays with different lengths or shapes, is deprecated. So what here happened is that in any dimensional array, rows should have the same size, and so we can't have varying rows in here. So the number of total columns is always the same among all the lists here. So let's remove this, and now if I run this, there should be no error, and if I print this out, it prints correctly. Okay, so even though nested lists and dimensions will be covered in further detail in the upcoming videos, right now I'm gonna give a brief introduction to what dimensions are and how do they work in NumPy library. So what basically happens is when we create a single dimensional array is that we have a list. Let's suppose all the elements are, let's suppose 3, right? And so this is a list. This is one dimensional. So in two-dimensional array, what happens is that we have a list, but inside that list, we have multiple lists. The number of lists can be any number, right? There can be thousands of lists. However, each of these lists should have the same length, which means the number of elements in each list should be exactly equal. This part gets a little bit tricky when it moves to three-dimensional arrays, three-dimensional numerical arrays. What happens is we have a list. Now inside that list, we have lists, right? This is just a two-dimensional structure, which is fine. Notice that it is exactly similar to the two-dimensional for now. Like we have a list and inside we have multiple lists. And so look right here. Now inside those lists, you guessed it, there are lists and so on. So what happens is that basically in a two-dimensional array, it's just a simple array, but the only difference is that it is made up of multiple one-dimensional arrays. All right, and in three-dimensional, what happens is that three-dimensional array is made of two-dimensional arrays. These are all two-dimensional arrays, right? All right, so I would like to draw your attention to this diagram. This explains a little bit better about the dimensions. So for example, we have a normal numpy array, which is one dimensional. This is a list, and these are the elements of the list. You can see there is one element in each of these index of list. Now each of these elements is an integer. Let's assume for a moment. What happens when we create a 2D array is that it creates a normal array, but each element of that array has to be a list, right? And so when we move on to the third dimensional, right? So we create an array, and each of the elements of that array is going to be a 2D array, right? And each element of a 2D array is going to be just a normal array. And each element of one dimensional array is going to be an integer, right? So that is like the basic structural idea behind multi-dimensional arrays in NumPy. And of course, you're going to study these dimensions and work with more complicated data. We'll study it in later videos in the pandas library. But for now, we'll just stick to 2D arrays and its properties. So let's go back to the workspace and see what else can we do. So we've learned about basic arrays in NumPy, and we've learned how to create 2D arrays. And now let's move on to a little bit of methods that can be applied on numpy arrays. And there are so many methods, and they give so much information about the numpy arrays that can be used to manipulate, access, and change data in those arrays. Okay, so the ndim method basically gives us the number of dimensions that we have. So if you look here, there is a array b, which is a two-dimensional array. And if we apply b dot ndim, and if you're not on collab, you can just do print. Yeah, and this should result in the same thing. So there are two dimensions of this array, right? And then we move on to the shape method. What it does is basically tells us how many rows and columns our array has. So if you go ahead and do b dot shape, it says like 2 rows and 3 columns. So there are 2 rows like this, and there are 3 columns vertically, right? And so if we are gonna add another row here, for example, another list here, 9, 4, and 3, right? And if I run this, you can see there is another row added. And now if I run this b dot shape, you can see it's like 3 rows and 3 columns. Moving on, another method that is like important is the data type. So we know that int32 is the default data type that the numpy uses when dealing with numerical data, right? But if we are making a new array, we can specify what data type to use. But for now, let's just write b dot d type. This is the method for getting the type, right? Or so what we're gonna do, run this, and right now it says int 64. Okay, so int 64, even though I mentioned here that int32 is the default data type that numpy uses when dealing with numerical data, and above I have not mentioned specifically that my data type should be int64. But right now it's showing int64, and the reason for that is that the default data type as of right now in numpy depends on the operating system or the computer system. And so if you have a 64-bit Windows, the default value is going to be int64. And so let's define a new array equals numpy dot array. We're gonna just put some random numbers in, right? And comma here outside the list, and d type equals, we're gonna put in int 16, right? So now if I print new a dot data type, right, and I remove this, let's run this, it shows int 16. Now we have specifically mentioned that the data type for this array is going to be a 16-bit integer, which is basically a 4-byte stream. All right, so let's go ahead and see if the new created array is the correct size. So what we're gonna do is we're gonna type in array dot item size, right? And we're gonna print that. And if I run this, I should get basically 4 bytes. Okay, so if I'm gonna get the total size, what I'm gonna do is I'm gonna say new a dot n bytes, right? And I'm gonna print that. So to print that, it will basically give me the total number of bytes in the new a array. So so we have 3 elements here, each of 2 bytes, right? So it should give us basically 6, right? Okay, so we usually specify the size of the initialization of an array whenever we are dealing with data that we need to be more efficient about. And I would usually normally leave it, right, and let the numpy handle that. Let's move on to accessing and changing elements, rows and columns. All right, so in this section, what we're going to do is we're going to learn about a little bit of operations that we can perform on numpy arrays for accessing and changing specific elements, accessing rows, accessing specific columns, and so on. But of course, this section will be covered in the next video in this course, and for now I think this is more than enough things to practice in one video. So I'm going to put some links in the description so you can read more about them and practice playing with numpy arrays. In the next video we're going to continue learning about numpy library, and we're going to start off with accessing and changing elements, rows and columns in numpy arrays. And so with that being said, thank you so much, and I'll see you in the next video.